quick look here and see. All right, we have a special request for number 8. Okay, so again, for those of you guys who are having trouble. All right, here we go. I think it's good to mark what they give you. All right, we know that from A to B is 6y. All right. So this right here is 6y. And then BC is 8y. All right, we know that's true, correct? And then they're asking about what? But BD is the same as what? Right, so that's not a big deal, right? BD is the same as AC, do you agree or not? So now we know this is a rectangle, correct? So we know that's a right angle, right? So now it's just A squared plus B squared equals C squared. 6y squared plus 8y squared equals C squared. 36y squared plus 64y squared equals C squared. 100y squared equals C squared. So 10y is equal to C.
Wait, how is the 18y squared? Because he's smart.
Okay, so here we go. Anybody have any other questions about that issue? Yes, what? How did you do that? What did we say yesterday with the distance formula? What did I tell you? How do you solve that using the distance formula?
I don't
Anybody want to tell them?
Me too. X squared minus x1 squared. Yeah, that's what I meant. Plus y.
But what distances are we checking?
A to B and B to C. You do the slope and then you do it in like.
One, I said exactly what to do yesterday. Using the distance formula. KK, do you remember?
I just did a lot. First, I found the distance from from A to B, and I just did the X or X2.
No, but I'm saying in a rectangle, someone else, what was it with?
It's the one with the opposite reciprocals.
Yeah, but that's telling you that the lines are perpendicular. It's not telling me about I'm not interested in the slopes. I'm not interested in the slopes. I'm interested in the distance formula. All right, so how would I solve, or how do I know that that's a rectangle? All right, just because the opposite sides are equal doesn't make it a rectangle. You can't measure AB and CD. Does everybody agree with that? Benji, what? Just because, do we agree the opposite sides don't matter, right? The diagonals have to be what? Equal. If the diagonals are equal, it's a rectangle. If the diagonals are equal, it's a rectangle. That's what I said yesterday. Or you could look up in your notes. And does it say anything? The what? What does it say right there? The diagonals are congruent. The diagonals are congruent. So the easiest way to determine if a quadrilateral is a rectangle is to measure the what? To measure the diagonals. All right, that's what I said yesterday. Measure the diagonals. If the diagonals are congruent, then it's automatically a what?
Do we measure the distance of how long the diagonals go, or their slope?
Well, let's say I'd have no clue. Let's just say I'm not even aware. So let's go -3, 1. Let's just plot it out. -3, 3, 3, 3, and 3, 1. Now I know it doesn't take a rocket scientist to say that's obviously a what? That's obviously a rectangle. All right. Now the question is, how do I know it's a rectangle? All right. We are simply going to do what? We're going to say -3, 1 is A, -3, 3 is B, and then this is C and this is D, right? So what has to be true? So what is the diagonal? What diagonals? BD is congruent to AC. So I look at AC. Now, obviously, this is 2, right? And then this is 6, correct? So AC is the square root of 40. Thank you. Now, is there any difference with BD? Is there any difference with BD? So it's going to be still what? Square root of 40, but because we're smart, we're just going to say that's 2 radical 10, 2 radical 10. All right. I'm listening.
Instead of doing all of that, couldn't we just count the distance from A to B and D to C, and those are both 2, and then B to C and A to D, and those are both 6, so doesn't that make it a rectangle?
That's what we just said.
Then why did we do the diagonals? That makes it like.
Does it necessarily make it a rectangle? That's what I'm asking you. That because the opposite sides are equal, is it a rectangle? Shh, I'm asking a question. I don't care what it says. I'm asking you a question. If the opposite sides of a quadrilateral are equal, is it a rectangle? Yes or no? No, we don't know. Could it be? Yes, it could be. So knowing that this is 6, and this is 2 does not make it a rectangle. Your observation makes it a rectangle because you know these are perpendicular. Now, we know they're perpendicular because the slopes are negative reciprocals. However, over here it says using the what? Slope formula. So if you want to prove that a quadrilateral is a rectangle, you look at all 4 slopes. If all 4 slopes are negative reciprocals, then it is a what? It is a rectangle. 2 of them will be congruent, 2 of them will be congruent, and then the 4 lines, all 4 slopes will be, 2 of them will be congruent, and 2 of them will be negative reciprocals. All right? That's all I'm asking. All right? And yesterday I thought I made that clear. To calculate the easiest way to determine if something is a rectangle, right, is to calculate the distance of or the length of the diagonals. That's how easy that was. That's it. What?
Up here it says, if opposite sides are congruent, then it's a rectangle. Like it's one of the properties.
If you know it is a rectangle, if you know it is a rectangle, if you know it is a rectangle, then what?
Well, then the opposite sides are congruent.
That is correct. Now, why did I tell her that? Do we know if the opposite sides are congruent? Does that make it a rectangle?
No.
I'm asking you.
Well, I don't get why it wouldn't.
It could be a square.
I don't, this is the thing I'm just puzzled about. Draw a figure that's opposite sides are congruent, that's not a rectangle. Draw it. Are the opposite sides of a square congruent? So a square still is a rectangle. Yeah, that's true. A square is a rectangle.
So how could it not be true then?
Draw one and show me. Try to draw a quadrilateral that's not a rectangle. Draw a quadrilateral that's not a rectangle. Wow, there you go.
Okay.
Come on, I'm frustrated because you just want the answer. That's what you want. You just want the answer. I prefer you think about it. All right. These are called what? Special parallelograms. So I told you, every property of a parallelogram applies to a what? Every property that you learn for parallelograms applies to the what? The rectangle. The rectangle is a special what? It's a special parallelogram. So in a parallelogram, are opposite sides equal? Does a parallelogram have to be a rectangle? No. I can draw a parallelogram without it being a rectangle. And if I draw a parallelogram and the diagonals are equal, then it's a what? Rectangle. If I draw a parallelogram in which the diagonals are not equal, then it's not a what? It's not a rectangle. All right. All of the properties of a parallelogram apply to the rectangle. The rectangle is just a special parallelogram. And it's special because the diagonals are what? The diagonals are equal. And what's true about the sides? Yes, they're perpendicular. That's it. That's what I'm trying to tell some of you guys. We're going to take a huge test and you're expected to know everything. Is it possible to know everything? No, it's not. It's not. I promise you. Those of you guys who are memorizers are going to try to sit and go home and memorize 150 rules. And I don't think it's necessary. I think it's necessary for you to understand what a rectangle is. And when I was unsure about something, I just drew a rectangle, and that's a pretty good rectangle. And then I drew this diagonal here, and then I drew this diagonal here, and I said to myself, wow, self, those diagonals look what? They look equal, right? Then I would come over here and do something crazy when someone asked me about a parallelogram. And I know some of you guys ask me questions and you see me thinking about it. Well, that's not a very good one, but we'll do this. Try to see how my still not wanting to work. So there we go. Now, this right here, I'm going to try to tilt this way. And this I'm going to try to tilt until I can see that's not the best. But that's a pretty good parallelogram, correct? So then I would make it so that it was exaggerated. And what do I mean? Because now when I drew that diagonal and I drew that diagonal, they're obviously not equal. So anytime you have a diagonal and you start to tilt it, one diagonal gets what? Smaller and one gets larger. That's what I want you to be able to do. Stop trying to remember everything. All right. Now, because it is a parallelogram, we can start marking things. And you can say, wow, this is equal to this. And you can come over here and say, that's equal to that. Right? You can do all kinds of things. And you can start to say, wow, the top triangle is the same as the what? And the right and the left triangles are what? The same. Then you can start saying, wow, this angle over here is equal to this. There's so many things you can just figure out just because you're smart, not because you just memorized 150 rules. All right, that's what I want you to be able to do on all of these. And in a minute, I'll give you another worksheet that has kind of, something else. All right. And instead of trying to remember more rules, you just have to understand the basic definitions. All right. So hopefully that cleared everything up. All right, before I collect this, does anybody have any issues? Nobody's telling me to have any issues. Math issues, let's stick with that.
So for number 24,
All right, so number 24, the distance formula.
if you were drawing up, cause like, cause I know you need the distance between each, like of the points in the rectangle on the diagonal.
Yes. You have to make sure that,
It's a radical, it's distance is a radical.
meaning like square root of 13,
It's like from Q to N is like 3 radical.
Q to what? But now again, I used to think if I give you, now this is a good question. So listen, so NOPQ, I never used to just assume the points were in the correct order, right? Because look up here at this one I drew. Do we agree AB, it's in the right order, right? So if it's in the right order, this is the diagonal and this is the diagonal. Do you agree with that? But I never used to like to assume that because once on a test, they would switch the letters up and, you would automatically do the sides instead of the diagonals. So I understand what I'm saying. So if I were you, every single time I had this problem, I would just plot these points real quick, right? So if I had -4, 5, I'm going to put -4, 5, 6, 0 over here. 3, -6 would be here. And then -7, -1 would be here. Right? So -4, 5 is N, 6 is O. So they are in the right order. Do you agree?
Yeah.
So all I have to do is calculate what NP is. Do you agree?
Yeah.
And calculate what QO is. Do you agree with that? And so NP, right? If I'm looking at NP, I'm subtracting the X's. -4 minus 3 is 7. 7 squared is 49. Plus 5 plus 6 is 11. 11 squared is 121. So that's the square root of 170. Is that what you got? Yes or no? You agree?
No, I did it.
I'm okay now, but all I care is you understand now. Right? That's all I care about you. And now I'm going to check OQ. It says determine whether it's a rectangle. So is this a rectangle?
Yes.
6 plus 7 is 13. 13 squared is 169 plus 1, square root of 170. So I know it's a what? I know it's a rectangle, right? Because the diagonals are equal. Everybody happy with that? Everybody's good? Tell me.
You're drawing a factor, you draw something you needed at all.
No, I don't. No. I think it's just a reference, right? But I put those in there for a reason. For some like me, I would never trust that I could just look at that and say that NP is the diagonal, right? I would like to plot the points to make sure I'm not being tricked, right? Because do you agree I can put these points out of order?
Yeah, I mixed up -7 and -1, so I got like a trapezoid thing.
Well, and that's why you have to be careful. But even if you plot them incorrectly, you should be able to see which one's what, right?
Yeah.
You know what I mean? So just be careful. Go ahead. Thank you.
On that question, I thought you were allowed to prove that it was a rectangle by finding slopes and then their opposite reciprocal.
For which one?
For the one we were doing, the one.
What does it say right here, kiddo? But guess what? I don't really care. I really don't.
So
But I'm just saying for me, checking the come on, guys, do we agree? Checking the diagonals are equal is the easiest one. You can do the slopes of all four if you want. Right? Do you understand what I'm saying? Like I need to do over here. I need to find the slope of BG. I need to find the slope of GH. I need to find the slope of HL. And I need to find the slope of BL. I need to find the slope 4 times. And 2 of them are going to be equal and 2 of them are going to be opposite reciprocals. Am I right?
Why are we squaring it? Like, why are we squaring the 7 and the
What is the distance formula?
It's
X2 minus X1 squared plus Y2 minus Y1 squared. Or I told you a million times, it's A squared plus B squared equals C squared. I didn't even know the distance formula for the longest time. Right? Because I couldn't remember all these properties and rules, but I was fascinated with A squared plus B squared equals C squared because a lot of things come from that. And that I just made it every time someone asked me what's the distance between 2 points, I just made a what? I just made a right triangle. And I literally counted from here to here. And then one day I woke up and said, wow, I'm finding the distance between these 2 points. What do? I subtract the x's. And if I want to find the distance between these 2 points, I just subtract the what? And there you have the formula for distance formula. I was like, wow, I could have saved myself a lot of time if I'd have just thought about it a little bit. That's why I'm trying to show you guys. I'd much rather you think about it than try to just remember everything. Math's fun if you don't have it all memorized, right? You think it through and realize how logical it is. And some of you just insist on trying to remember everything because you think you're not the greatest math student. It's farthest from the truth. You just learn it, right? Understand it. It really and truly isn't that difficult. And you know what? When you learn it, I don't have to remind you when you're a junior, when you're taking your SATs, all the formulas, right? That would be kind of nice. All right. It's just information that you can figure out. All right. Anybody else? Hopefully that cleared everything up. All right. Because if this makes sense today, the next worksheet I'm going to give you is going to be what? Easy. Right? I think it's a rhombus. What's a rhombus?
Like a diamond thing.
A what?
A diamond thing where like they're.
What? All sides are equal. That is correct. All right, please. A tilted square. Exactly. Thank you very much for that information. All right. Discovering these. All right. So now we have special parallelograms. All right. The rhombi, which is just plural for rhombus, right? And squares. All right. What's the difference between a square and a rhombus? Right. A rhombus does not have 90-degree angles. All right. But certainly all of the sides are congruent. Does everybody agree with that? So now, once you realize that all the sides are congruent, and then you draw in the diagonals, all right? Because the sides are congruent and the diagonals bisect each other, does everybody agree? So here's what I'm trying to teach you. I marked the figure, so all of these are equal. Now, remember what I told you, all the properties that apply to parallelograms also apply to the what? Rhombus, because a rhombus is a what? Parallelogram. So all the rules apply. So that means this right here has to equal this right here. Do we agree? And that means this right here must equal this right here. Do we agree? Now again, I'm trying to show you how I remember doing all these lessons and going, there's just no way I can remember all these rules. So I learned that I just looked at that, just based off my own little basic information, what's true about all four of those triangles. Well, I know, but first and foremost, you are going to say that in a minute, but first and foremost, I need to know that all four of those triangles are what? Equal. They're equal. Why are they equal? Because there's 1 tick mark, 2 tick marks, and 3 tick marks. So all four are congruent by what? By side. We don't know it's 90-degree angle yet. That's why I'm saying, listen, please. I marked them congruent for a reason. All right. I'm trying to demonstrate. We know it's a rhombus. Let me say one more time before I get. These are all equal. Do we agree? The diagonals bisect each other, correct?
Yeah.
So this was equal to this. And then this was equal to this. So I'm just, from my own basic observation, I did nothing on the figure. I just proved that all four of those triangles are what? Congruent by what? Side, side, side. So now, if BHR is congruent to BMR, then this right here, Brooks, must be a what? And because we know it's a right angle, these angles are congruent by CPCTC. So if two angles form a linear pair and they're congruent, they must be what? Perpendicular. I know that's a fancy word, but of course that's obviously true. That's how I learned the rules. All right. I drew a rhombus, drew the diagonals, and then made a revelation that all four of those triangles are congruent. So now I know that the diagonals of a rhombus are what to each other? Perpendicular to each other. Thank you. All right. And that's what they're trying to tell you up here. All right. The diagonals are perpendicular. The diagonals are perpendicular. Now, let's look at the diagonals. What's true about this angle right here and this angle right here, people? That angle is being bisected by the diagonal, but how do I know that it's... No, I know it says it. It's you sit and taking a test, and now you're gonna have to tell me that's true. It's the rules aren't going to be posted for you. So I'm asking you, how do I know that those two angles right there are congruent? No. CPCTC. We said, please, again, I'm trying to make it so you're not frustrated when you're taking your test, because some of you are going to walk out and be upset. All right, it happens every year. All right, and I'm trying to tell you, don't be one of those. All right, why is this angle right here equal to this angle right here? Because the top triangle and the right triangle are what? Congruent to each other. So that means that this angle here is congruent to this angle here, correct? That's what that means. All right, so that means that this diagonal bisects the angles. I didn't need them to tell me that. I don't need them to tell me that. I discovered that on my own. All right, I don't need to remember any of this about the square or about the rhombus. All right, I just drew it out every time on my test, and I drew a square, drew a rhombus, and drew the diagonals and said, there, that's true. All right, that's always true. All right, so for those of you guys who are much better at just memorizing facts, there's more facts for you. All right, bless you. Anybody have any issues with that? All right, go ahead, jump in.
Oh, it's just a statement.
Oh, I'm dying to hear, go.
You know how that shapes a rhombus? All the letters almost spell.
Oh, that was a great observation. They should have just, they should have just made it an I here, right? And then it would be rhombi. There we go. Oh, hilarious. Okay, here we go. Now we're going to talk about the square. All right. Now, again, I'm not sure some of you understand what I'm saying. A square is a special what? Even better, I could say a square is a special rhombus. A square is a special rhombus.
Yeah, right. I just said that because
A square,
And the square's like the original.
yes. Is a square always a rhombus?
Yeah.
Is a rhombus always a square? No. All right, so a square is a special rhombus. A square is a special rhombus because the sides are perpendicular. That's what I'm trying to get you to understand. All right, so every rhombus is not a square, but every square is a rhombus. Every square is a parallelogram, yes? But not every parallelogram is a square. Every property of a or of a parallelogram applies to a what? Square or a rhombus. Does everybody agree with me? But every property of a square does not apply to a parallelogram. That's what people get confused. All right. But if you learn to draw the figure and draw the diagonals, it's really easy to see. All right. So is a square a rhombus? Yes. So the properties of a rhombus apply to a what? Square, except the diagonals of a rhombus or the diagonals of a square are now what? Congruent, because a square, believe it or not, is also a rectangle. All right. So I figured out that as long as the sides are perpendicular, then the diagonals are what? Equal. Thank you very much. All right. Again, if you don't like it, on my test, I always drew out the square, the rectangle, the rhombus, and I drew out the parallelogram. And then I just looked at it and it was obvious once you look at it. All right. So these are the properties. If the diagonals of a parallelogram are perpendicular, then it definitely is a what? Rhombus. If the diagonals are perpendicular and congruent, it's a square. Right. Now, those are a lot of words coming out of my mouth. And I'm not saying you should be able to just rattle those off. I'm saying instead of just randomly saying something, think about it. All right? Think about it. If the sides are perpendicular, the diagonals are equal. All right? And a square is really nice because all four triangles are still congruent because it's a rhombus, but the inside triangles are now what? Right triangles also. All right? Yes. A rhombus is not always a square. That is true. But a square is always a what? Yes. So you can look at something and say, I know that's a rhombus. It might be a square. But the angles have to be exactly what? 90 degrees. Right? But you could look at, like, for example, just to show you, right, what I mean by this is I could draw this. Well, not that. There. That looks like a square. Right? But this angle right here might be 89 and this might be 91. You see what I'm saying? So until they mark it, right, then, right, we have no idea. Then all of them are, wow, very brilliant. See, that's exactly correct. All right, because consecutive angles are supplementary. In a parallelogram, consecutive angles are supplementary. So if one is 90, they're all 90. That's exactly right. All right, so I feel like we've made some progress today. And again, here it's saying the rules. I don't think I need to read any more to you. All right. Now, determine, let's look here. Determine whether it is a rhombus, a rectangle, or a square. List all that apply. So if it's a square, then it's a what? And a what? And it's all of them, correct? Do you agree with that? You can be a rectangle, and if you're a rectangle, you're not a square or a rhombus, correct? Right.
It could be a square.
Well, if you're a rectangle, then you're correct, but I'm assuming you're seeing this. This is a rectangle. Right?
Yeah.
So it's definitely not a square. Right. I understand what he's saying, right? So the question is, how do we differentiate between what's the easiest thing to do? Right? So if the diagonals, it can all be done with diagonals. So let's summarize this real quick. All right. If the diagonals are equal, it's a what?
Rectangle.
A rectangle or a what?
square.
I know what you meant. If the diagonals are equal, it's a rectangle or a square, correct? Does everybody agree? Then you can do the slopes, correct, of the diagonals. If the slopes of the diagonals are negative reciprocals, then it's automatically a what? How's that a rectangle?
Like that,
Square.
and one's like that.
Well, I don't even know what that means. One's like that and one's like that. I asked you a question, right? Yes, you're saying things. Come on, girl. Duplicate. Here we go. I blow this up. What are the diagonals? Are they perpendicular? No. So you calculate the slopes of the diagonals. If the slopes of the diagonals are perpendicular, then it must be either a what? Rhombus or a square. You with me on this? Right? And if the diagonals are equal, then it's a square. Is everybody with me on this? Right? Provided that, all right, I feel like I'm having to write all this out. I don't really feel like it. So we're determining if it's a rhombus, a rectangle, or a square, right? So we want to check the diagonals. If the diagonals are congruent, then it's a what? Rectangle or a what? It's a rectangle or a square. So now I had checked for the what? The slopes, right? If the slopes are what? Negative reciprocals, then it's a what? Square. If they're anything other than negative reciprocals, then it's a what? It's a rectangle. You with me on this? Right? If the diagonals are not equal, then it's automatically going to be a what? It's automatically going to be a rhombus because it says, given each set of vertices, determine whether the parallelogram is a rhombus, a rectangle, or a square. Is everybody with me on that? So if it's not congruent, then we can automatically say that it's a what? It's a rhombus. Is that clear? Yes. I'd never do that. Oh, but look, it's safe to do that. And the reason why it's safe to do that is because it lists it as A, B, C, D. You hear what I'm saying? Does that make sense? If it just said parallelogram, or if it just said quadrilateral, determine whether the quadrilateral is a rhombus, a rectangle, or a square, then I wouldn't assume that A, C, and B, D are the diagonals. That's a good question. Do you hear what I'm saying? Right, but you see what I'm saying, right? It lists it as this is the parallelogram. It's telling you that it is a parallelogram. So all I'm doing is checking the diagonals, so you're very smart. A, C, and B, D. I think that's why I didn't put the graphs up there, because I wanted you to understand the relationship between the diagonals.
So if we find out it's a square, can we then just say it's a rectangle?
Yeah, every square is a rhombus. That's true. That's why they said list all that apply. You agree with that?
What is a rectangle?
A square is definitely a rectangle also, because the definition of a rectangle is opposite sides are congruent and the angles are 90. Believe it or not, a square is a rhombus and a rectangle. Oh, no. So you're right. I don't know what I was. So a square is a rhombus. That's correct. And a square is also a rectangle.
So say like I got that one of them was square, then I would have to say it's a rectangle and a rhombus.
Yes,
But how can it be rhombus?
because a rhombus, right? So I understand your confusion. Here is a square. The definition of square is all sides are congruent and all angles are 90. The definition of a rhombus just says, come on, whatever. The definition of rhombus just says all sides are equal. right? And the definition of a rectangle says opposite sides are equal and the angles are 90 degrees, right? So if you have a square, does it meet that condition? Opposite sides are congruent and all angles are 90. Does it meet the definition of a rhombus? So a square is both a rectangle and a rhombus. Correct, but if I look at that and say that's a rhombus, it doesn't have to be a square. Right? All right, they're tricky. That's why you got to get them in your head. All right, understand what I'm saying. All right, guys, have at it. I don't think it's that difficult. All right. Please get busy. Finish up as much as you can. I don't want you to work that much, but you're going to. Yeah.